Imagine waking up one morning and reaching for your trusty compass, only to find its needles spinning in wild, unpredictable circles. The familiar sense of direction you've always relied on is suddenly gone, replaced by a strange uncertainty. You step outside, expecting the world to look the same, but something feels off. The very foundation of how you navigate the world, how explorers, travelers, and even animals have found their way for centuries, has been thrown into chaos. North is no longer north, and south is no longer south. The directions you've always trusted are now unreliable, as if the world's invisible map has been scrambled overnight. Imagine the confusion, not just for you, but for everyone who depends on these cardinal points: pilots, sailors, hikers, and even the technology in your smartphone. Suddenly, the rules of navigation have changed, and the world feels unfamiliar. Birds, who have long relied on Earth's magnetic field to guide their epic migrations, now fly in confused, erratic patterns. Their internal compasses, honed over millennia, are thrown into disarray. Flocks circle aimlessly, unsure of which way to go, while scientists scramble to understand how these creatures will adapt to a world where their most basic sense of direction has been upended. Meanwhile, the night sky comes alive with breathtaking displays of color. The auroras, those shimmering curtains of light usually reserved for the far north and south, now dance across the skies in places where they've never been seen before. Cities and towns that have never witnessed these natural wonders are suddenly bathed in vibrant hues of green, purple, and red, captivating people around the world and sparking awe and curiosity. It might look like a scene straight out of a science fiction movie, but this is a real possibility, one that scientists have studied for decades. If Earth's magnetic field were to flip, the effects would ripple across the globe, touching everything from wildlife to technology, and even the way we experience the night sky. Yet, despite the dramatic changes, life would go on. It might sound like a recipe for global chaos, but rest assured, it's not the end of the world. People would adapt, just as they always have. Daily routines would continue, cities would keep bustling, and families would gather at home, finding new ways to navigate and understand their changed environment. Humanity has always been resilient in the face of change, and this would be no different. In fact, Earth's magnetic field has flipped many times throughout its long history. Fossil records and ancient rocks tell the story of a planet that has endured countless reversals, each time allowing life to adapt, evolve, and thrive. From the tiniest microorganisms to the largest mammals, life has always found a way to survive and flourish, no matter how the world turns upside down. Our planet is not just a solid sphere of rock and water, it is a living, breathing system, constantly in motion and full of hidden wonders. While we often think of Earth as a stable, unchanging place beneath our feet, the reality is far more dynamic and complex. Deep beneath the surface, forces are at work that shape not only the land and oceans, but also the very environment that makes life possible. At the heart of our planet lies a core made mostly of molten iron and nickel, swirling and churning in a constant fiery dance. This core is incredibly hot, hotter than the surface of the sun in some places, and its movement is the engine that drives one of Earth's most important features, its magnetic field. Without this restless molten heart, our world would be a very different place. The movement of this liquid metal generates powerful electric currents, a process known as the geodynamo. These currents create a vast, invisible magnetic field that stretches far out into space, wrapping our planet in a protective cocoon. Scientists have spent decades studying this phenomenon, using laboratory experiments and computer models to better understand how the geodynamo works and why it is so vital for life on Earth. The magnetic field acts as a shield, deflecting charged particles from the sun, known as the solar wind, and preventing them from stripping away our atmosphere. Without this protection, the solar wind would gradually erode the air we breathe, making Earth as barren as Mars. The magnetosphere also helps to protect us from cosmic rays and other forms of harmful radiation that constantly bombard our planet from deep space. Sometimes, when solar particles do manage to slip through the magnetic field near the poles, they collide with molecules in our atmosphere, creating the breathtaking displays of light known as the aurora borealis and aurora australis. These natural light shows are a visible reminder of the invisible forces at work high above us, silently guarding our world. The magnetic field also plays a crucial role in navigation. For centuries, explorers and travelers have relied on the steady pull of a compass needle, which aligns itself with Earth's magnetic field, always pointing north. This simple tool has guided countless journeys across oceans and continents, making exploration and discovery possible long before the age of satellites and GPS. But Earth's magnetic field is not fixed or unchanging. Over time, it shifts and fluctuates, sometimes even reversing its polarity, so that north becomes south and vice versa. These magnetic pole reversals have happened many times in our planet's history, and while the process is slow, it is a powerful reminder that our world is always evolving. Today, scientists use sensitive instruments to monitor the magnetic field, tracking its subtle changes, and trying to predict what might happen in the future. Understanding Earth's magnetic field is not just a scientific curiosity. It is essential for protecting our technology, our environment, and ultimately ourselves. The history of Earth's magnetic field is etched in stone, literally. When lava cools and solidifies into rock, iron-rich minerals within the rock align themselves with the direction of Earth's magnetic field at that time, like tiny compass needles frozen in place. By studying the magnetic orientation of these ancient rocks, scientists have discovered that Earth's magnetic poles have flipped hundreds of times throughout our planet's long history. These flips are not regular or predictable. They occur at random intervals, ranging from tens of thousands to millions of years. The last full reversal, known as the Brunhes-Matuyama reversal, happened around 780,000 years ago. So what exactly happens during a magnetic field reversal? First, the field doesn't simply switch instantly. It's a gradual process that can take hundreds to thousands of years to complete. During this transition period, the magnetic field weakens and becomes more complex, with multiple poles appearing at different locations. This weakening of the magnetic field would have a number of effects. Compasses would behave erratically, pointing in different directions depending on their location. The auroras, typically seen near the poles, would become visible at lower latitudes as charged particles from the sun penetrate deeper into the atmosphere. While a weaker magnetic field might make for some spectacular light shows, like the aurora borealis painting the night sky with vibrant colors, the consequences go far beyond just beautiful scenery. These dazzling auroras are actually a visible sign of charged particles from the sun interacting with our atmosphere, and they become more frequent and intense when the magnetic field is weaker. But as we marvel at these natural wonders, we must also consider the hidden dangers that come with them. The Earth's magnetic field acts as a protective shield, deflecting much of the harmful solar and cosmic radiation that constantly bombards our planet. When this shield weakens, more of that energy can reach the surface and our technology. Our modern world is built on a foundation of technology, and much of it is surprisingly vulnerable to changes in the magnetic field. Power grids, which deliver electricity to homes, businesses, and hospitals, are especially at risk. The vast networks of wires and transformers that make up these grids can act like giant antennas, picking up electrical currents induced by geomagnetic disturbances. Even a relatively minor fluctuation in the magnetic field can cause surges that damage equipment, trip circuit breakers, and in extreme cases, lead to widespread blackouts that can last for hours or even days. Satellites orbiting Earth rely on the magnetic field for protection from harmful radiation. These satellites are essential for everything from global communications and navigation to weather forecasting and scientific research. Without the magnetic field's shielding effect, satellites are exposed to higher levels of radiation, which can damage their sensitive electronics, degrade solar panels, and even shorten their operational lifespans. This increased exposure can lead to more frequent malfunctions, loss of data, and interruptions in the services we depend on every day. A weakened field could expose satellites to higher doses of radiation, potentially disrupting communication systems, GPS navigation, and weather forecasting. Imagine trying to navigate a city without GPS, or airlines losing access to real-time weather updates. Even financial transactions, which rely on precise timing signals from satellites, could be thrown into chaos. The ripple effects would be felt across industries and daily life, highlighting just how interconnected and dependent we are on space-based technology. On the ground, power grids are also vulnerable to the effects of a weakened magnetic field. The risk isn't just theoretical. History has shown us what can happen. In 1989, a powerful geomagnetic storm caused a blackout in Quebec, Canada, leaving millions without power for hours. As our reliance on electricity grows, so does our vulnerability to these kinds of events. Geomagnetic storms, caused by bursts of solar activity, can induce electric currents in power lines, causing blackouts and widespread damage. These storms can also damage transformers, which are expensive and time-consuming to replace, potentially leading to prolonged outages. Utility companies are working to make grids more resilient, but a significantly weaker magnetic field would make their job much harder, increasing the frequency and severity of these disruptions. A weaker magnetic field would provide less protection from these storms, increasing the risk of power outages and disruptions to our increasingly electrified world. As we continue to advance technologically, our dependence on reliable electricity and satellite-based systems only grows. Understanding and preparing for the risks posed by a changing magnetic field is crucial, not just for scientists and engineers, but for everyone who relies on the invisible forces that keep our modern world running smoothly. Humans aren't the only ones who rely on Earth's magnetic field. Many animals, from birds to bees to sea turtles, possess a remarkable ability to sense the magnetic field and use it for navigation and orientation. These magnetoreceptors allow them to migrate across vast distances, returning to the same breeding grounds year after year with astonishing precision. During a magnetic field reversal, with its fluctuating strength and multiple poles, these animals would face a confusing and potentially disorienting environment. It's unclear how this disruption would impact their migratory patterns and survival, but it's likely that some species would adapt better than others. Beyond satellites and power grids, a magnetic field reversal could have other, more subtle effects on our technological world. Radio communications, for example, rely on the ionosphere, a layer of Earth's atmosphere that is ionized by solar radiation. The magnetic field plays a role in shaping and protecting the ionosphere, so a weaker field could lead to increased radio interference and disruptions to communication systems. Even our daily lives could be affected. The increased radiation exposure from a weakened magnetic field might lead to a slight increase in cancer risk, although the exact level of risk is still debated by scientists. While the prospect of a magnetic field reversal might seem alarming, it's important to remember that this is a natural process that has happened many times before. And crucially, it's a slow process. The gradual weakening and eventual flip of the magnetic field would take place over centuries, giving us ample time to adapt and prepare. Scientists are constantly monitoring Earth's magnetic field for any signs of change. They use a global network of observatories and satellites to track the field's strength and orientation, providing valuable data that helps us understand the dynamics of our planet's invisible shield. Earth's magnetic field is a reminder that our planet is not a static, unchanging sphere. It's a dynamic system, constantly evolving and reshaping itself over time. While a magnetic field reversal would undoubtedly bring challenges, it's also a testament to our planet's resilience and our own capacity for adaptation and innovation. As we continue to explore the cosmos and unravel the mysteries of our own planet, one thing remains certain: Earth is a dynamic, ever-changing world, and we, as its inhabitants, have an incredible ability to adapt, innovate, and thrive in the face of